Hi students, in this video we are going to look at the coefficient of determination. So after watching this video you should be able to explain the coefficient of determination, or R squared value, and its meaning in a context, and then use the R squared value to evaluate how well a model fits the data. Big things to recall: how to draw a scatter plot. All of our analysis that we're looking at in this series of videos has to do with scatter plots. And it's also important to remember that we've discussed another statistic to measure association and correlation, Pearson's correlation coefficient, and we're building on that idea in this lesson. All right, so the coefficient of determination is a very common and important statistic in situations where data is used to predict future outcomes. So whether it's predicting the amount of sales in the next quarter, or predicting how populations might change in an area, the R squared value basically gives us an idea for how a model to predict those things, how accurate could it be. Now, what does it actually mean in common language? Well, the coefficient of determination measures how well the explanatory variable explains or affects variations in the response variable. So again, let's look at an example sentence to actually see what that looks like. So if there's some mathematical model that fits a data set with an R squared value of 0.85, what that means is the explanatory variable can explain about 85% of the variation in the response variable. So that's pretty high. Right? So 85% of the changes in our response are affected by the explanatory variable, or is the best way to think about that R squared value. Now what that means is the higher the R squared value, the better it is at explaining the association or correlation between those two variables. Right? If our R squared value is 0.98, that means our explanatory variable can explain 98% of the changes compared to 85. So the larger the value, the better it is at explaining the changes or the variation in our variables, and the better it is at predicting values outside of the data set we're given, so extrapolating our data. Now, key thing is to note, if you're doing your line of best fit using technology that uses the least squared line to find the line of best fit, the R squared value is actually equal to the square of the correlation coefficient R. That's why it's R squared. All right, so let's now do an example. Evaluate the two lines of best fit for the data shown below using the R squared values. So our red line has an R squared value of 0.8523. Our black one has 0.9145. And we can see that the black one does fit the data a bit better. It's following the trend of those green dots a bit more accurately than the red line. Right? It looks as though those dots are traveling closer, more in line with that black line rather than the red one. Now, what we're going to do is write our peel paragraph. We won't have a link sentence because we're not linking it to anything, but we are looking for that paragraph that has our point at the start, some evidence, then explain what it means in normal day-to-day terms. So, how can we write that paragraph? That's what I've got here. So the black line is a better fit for the data than the red line because it has a higher R squared value. So there's my point sentence, right? Stating my key conclusion or point, the black line is a better fit for the data than the red one, and giving a short reason with the higher R squared value. So that's our point sentence. My next sentence is the evidence. So the evidence I can refer to is, again, just the R squared values. And what I'm going to do is explain them in common language. So I could just say the R squared value of the red line is 0.85, which is less than the R squared value of the black line, 0.91. But I'm going to take the opportunity here to actually demonstrate that I know what this value means and can explain it in common language, everyday language as well. So the evidence sentence I've got here is the black line can account for 91.45% of the variation between the two variables, whereas on the other hand, the red line can only account for 85.23% of the variation. And then finally, that last sentence is explained. So what does this actually mean? Okay, so because the black line is better, this means that the black line will provide a better prediction when extrapolating the data than the red line. So I've got my point, the evidence, and then an explanation there at the end to to form my evaluation about which line is a better fit for the data. All right, so students, after watching this video, you should be able to explain the coefficient of determination and its meaning in a context. Again, that's talking about what percentage of the variation the model can explain, and then also use the R-squared value to evaluate how well a model fits the data, which we did in our second example.